This video is going to look at finding the derivative of a constant and also looking at using the power rule. And before I look at these two, I want to quickly look at some of the different notations that we can use for indicating taking the derivative. So if we just have a function y equals f of x, the derivative notation could be what we looked at before, is just simply writing f prime of x. So this indicates that you're taking the derivative, or we could simply write y prime. Another notation you'll see is dy dx. And what this means is you're taking the derivative of y. Okay, so here's your function. We're taking the derivative of y, and the dx means we're taking the derivative with respect to the variable x. And later on, this will be more important, and you'll see the understanding of taking the derivative with respect to the variable x. Another notation would be something like this, where you have capital D little sub x of f. So again, if this is our function, y equals f of x, this says we're taking the derivative of f, and again, the little x indicates that's what we're taking the derivative with respect to the variable x. Another notation we'll see is d over dx, and then your f is in parentheses. So again, this is just simply saying we're taking the derivative of the function f, and the dx says we're taking the derivative with respect to the variable x. So these are just some of the common types of notation that you'll see throughout, indicating you're taking the derivative of your function. The most common that you will see will be this f prime and y prime and dy dx. The d over dx f, this a lot of times you'll see in the front of your book or sometimes in the formulas for the notation, because this is indicating that you want to take the derivative of whatever's in the parentheses f. So we're taking the derivative of function f with respect to x. And you'll notice over here when we look at the constant rule, that's what you're going to typically see in your formulas here with d dx of c, where c is just a constant number. So d dx of c means you're taking the derivative of the constant with respect to the variable c. And the rule says if you're taking the derivative of a constant, it's always going to be 0. So again, the notation says the derivative of what's in the parentheses, the constant, with respect to x. So again, you're taking the derivative of what's inside the parentheses. So if we look at this first example, notice here this says f of x equals 3. Well, if they don't tell us anything else to do, we don't know what we're looking for. So here I would have to say that this is your function, and then somehow you would have to indicate or be told that you want to find the derivative of that function. So here, if I say we want to find the derivative of f of x, we could write f prime of x then is going to be equal to, well, if f of x is equal to 3, from our constant rule, we know the answer is 0. Now, why is the derivative of a constant always 0? If you recall, what is the derivative? Well, remember, the derivative is the slope of your tangent line at a given point on your function. Well, if we graph our function, f of x equals 3, that's just going to be a horizontal straight line. So here we have f of x equals 3, and we know that if we're looking for the slope of this line, any horizontal line is going to have a slope of 0. And recall, that's what we're finding with the derivative. So therefore, anytime you have a constant, the derivative is simply going to be equal to 0. The next example, y equals 15. Same situation. Now again, here your directions would actually have to tell you that you want to find the derivative, because y equals 15 is just the equation. So your directions might say simply find y prime. So that means we want to find the derivative, and again, because this is a constant, the derivative of the constant would simply be 0. Now, if you look at our third example, Notice the notation here is d dx, the derivative of negative 201 with respect to x. This notation here is actually telling you we want to take the derivative of a negative 201. So for this case, you really don't need any more information other than this is telling you to calculate the derivative. So here, the derivative of negative 201 with respect to x, we know the derivative would simply be equal to 0. All right, if we move on to what's called the power rule, this is going to be one of the main rules here we're going to look at. The power rule says that if you're taking the derivative of x to a power, then you're going to take your power, which is the n is representing our power. We're going to take that power and we're going to multiply that in front of the x. So whatever your exponent is, that's going to be multiplied by x. And then the formula says you're going to take and subtract 1 from the exponent. So again, you can take the exponent, multiply, and then decrease the exponent by 1. That's what this n minus 1 is indicating. Okay, and yes, it is pretty much that simple. So if we apply that to the example here below, it says we want to take the derivative of x to the fourth, again with respect to x, and basically that means our variable here, which is x. So x to the fourth, we're going to take that exponent, move it out front, so we get 4 times x, and then we're going to decrease the exponent by 1, so we're going to end up with 4x cubed. Same thing over here, y equals x to the 10th. If we want to find the derivative of y prime, the exponent's 10, you would have 10 times x, subtract 1, so you'd have 10x to the 9th power. Okay, now, what if we look at this next example, y equals 1 over x cubed, and we're trying to find the derivative? Well, the first step here is to rewrite the problem. So if we rewrite the problem, we could rewrite this by moving the x cubed to the top, and if we move this x cubed to the top, this is kind of the opposite of what we normally do. We're going to end up with x to the negative 3rd power. So remember, normally what you have is if you have something like y equals x to the negative 3, normally you want to make your exponent positive, and we would take that x to the negative 3 and move it to the bottom to make it a positive 3. But in this case, we're going to do the opposite. We want to move this variable to the top, so we're going to make it a negative 3. And the reason we do that because now we can find the derivative very easily by moving the exponent out front, so we get negative 3 times x. Now be very careful. What do we have to do with this exponent? Well, we have a negative 3 and we need to decrease it by 1. So you have to be careful because it's negative. We're going to decrease it by 1, so that's going to be negative 3 minus 1, so therefore you end up with a negative 4. And that's your derivative. And your very last step would be we could actually rewrite this or simplify this. At this point, we could simplify. And all we're going to do is make our exponent positive, so we would have negative 3 over x to the 4th. Now be careful. We do not move the negative 3 because the negative 4 exponent is only with the variable x. So your derivative is negative 3 over x to the 4th. All right, we're going to do something similar with the example here on the right, y equals the square root of x. And you might be able to, if you want to pause the video, see if you can come up with a way that you can calculate the derivative, and then you can continue. Y equals the square root of x. Well, if we want to find the derivative, again, we're first going to rewrite the problem. And if you recall, we can rewrite the square root as x to the 1/2. And now we simply have our exponent. So therefore, we can have y prime equals, pull the exponent out front, 1/2 x. And again, you're going to have, be careful here, 1/2 minus 1. So you're going to end up with 1/2 minus 1 is x to the negative 1/2. And there's your derivative. And a lot of times it's not too big of a deal to leave your exponent as a negative, but if we want to simplify this, we could write it as 1 over, and again the 2's in the denominator, move the x down, and we get x to the positive 1/2, or we could write this as 1 over 2 times the square root of x. Either one of those would be correct. And you're going to find out the further you go, the higher you go in math, you're going to realize that when you're looking at the exponent here, a lot of times we don't really care if you leave it as a negative exponent. Sometimes it's just as well to leave it as a negative. Other times you will want to make it a positive exponent. So if we quickly review here, once again, the constant rule, the derivative of a constant, because you simply have a horizontal line, your derivative or the slope is always simply going to be 0. Power rule, if you have a variable raised to an exponent, you simply multiply the variable by the exponent and subtract 1 from the exponent.